Hey everyone, a very warm welcome back to the channel. And today we are starting with a very important topic, which is permutations and combinations. So, a very good level of problems we'll be having a look in this particular chapter. So, the very first question is 10 points are given in a plane such that no three of them are collinear and no four of them form a trapezium. From every point, all the possible lines are drawn, which are parallel to lines formed by taking any 2 points out of the remaining points. Find the total number of points of intersection of these lines, excluding, of course, the given 10 points already. So the maximum time allotted for this question would be 15 minutes. Ideally, you should try to do it within 6 minutes. And it is a really good problem. So you can pause the video, give the question a try, and then return back to have a look at the solution. So I hope you all have tried it out. Now the answer to this question would be 57,060 points of intersection will be there. Concepts and formulas used are simply permutations and combinations and the fundamental principle of counting, which simply means the multiplication principle itself, right? Now there are some observations that we'll be making. So the very first observation is that a line through one point cannot pass through another point, as that would mean trapezium formation due to parallel pair of lines, but it is already given to us that trapezium cannot be formed, so this cannot happen. Okay, so the thing is, let us assume this we are talking about this point, right? And we have assumed that by joining these 2 points, the line that is formed, we are going to draw this line parallel to that. Now, assuming that it passes through another point, that is not possible, because if this happens, then a trapezium can be formed using these green lines. So a trapezium has been formed, which is not possible. So basically what we are saying is that out of all the given 10 points, if you take any particular point and then choose any other pair of 2 points, and then you draw a line parallel to this one from this point, then it surely cannot pass through any other point. Okay, it will not pass through any of these. That's what we are trying to say. And there exists a bijection, which means one-to-one correspondence between any line through a point and its generator line. Now what we are trying to say here is that bijection means what? It simply means that if corresponding to every line there shall be a unique generator, and corresponding to every generator there shall be a unique line passing through that particular point. So obviously if we have a set of points just like this, and if I just talk about drawing lines from this point, and if I choose any other pair of points, then corresponding to this generator, of course there is only one single line that I can draw parallel to it through this point, right? That is very obvious. But how do we prove that corresponding to basically every line there shall be a unique generator? How to prove that? So let us assume to the contrary, that for this particular line, two possible generators are possible, AB and A dash B dash. But then you can observe that by joining through green lines, we can form a trapezium, which is not possible. So this line has been assumed to have two generator lines, which leads to a contradiction that a trapezium cannot be formed. Third observation is lines through two different points can only be parallel if they are both parallel to a common line joining two other points. So this point is a little difficult to grasp, but I'll try to explain. So let us say there are two different points, P1 and P2, and what we are trying to say is that let's say a line through P2 and a line through P1, let's say they are parallel. Then this can only happen if they have a common generator line not passing through the 2 points through which the lines themselves are passing, but they should be passing through two other different points. So how to prove this? Let me tell you. So look, let us say there are a lot of points, 10 points, and we are talking about these 2 points, and there is one line passing through this point, one line passing through this point, and they are parallel, let's say, of course. So parallel, let's say. So of course, it can always have a parallel, a line which basically acts as the generator line for both of them. Basically two different points which are generating a line parallel to which we are drawing this line and this line. So no problem there. But what we are trying to say is that this can be the only case. What we are saying is that the generator line cannot pass through one of these 2 points, P1 or P2 here, right? How to prove that it cannot be the case? Let me tell you. So let us say this is the point P1 and this is the point P2, and let us assume these are two parallel lines. Now let us assume to the contrary that the generator line can pass through one of these points, P1 or P2. Let us say it passes through P2. So if a line passes through P2 and let's say this is the generator line, then it means that this line must have been parallel to this also, because it is very obvious. Look, I'll tell you what we are trying to say. I'll tell you again. We are trying to see that whenever we'll try to draw all the lines through the point P1, so obviously that will be through generator lines, which will be due to two other points except P1. So if that other point also includes P2 and some other point, and joining them gives us a generator line, then obviously this line must have been parallel to this. But since it is also parallel to this line, these two lines must have been parallel, which is impossible because they both are passing through the same point P2. So if they are passing through the same point P2 and they also have to be parallel, it means they must be coincident, right? But the thing is, this line cannot act as a generator line because I have already proved that this line cannot pass through any other point except P2. And since it can't join two points, basically it can't join 2 points, so it can't act as a generator line, because according to the rule given in the question, that's what's happening. Like first we find a pair of points other than the point through which the line has to be drawn, and that is acting as a generator line. So by this contradiction we can see that two lines through two different points can only be parallel if they have a common generator line, right? And of course, they can't have two generator lines also. Why? The reason is, and why will it be unique? Let me tell you that also. So let us say this is also a generator line, this is also a generator line. So the line through this point must be parallel to this also, and it must be parallel to this also. It means these two must be parallel. But that is again a contradiction, because if there are two generator lines that are parallel, trapezium formation would take place, which is again given in the question not to be the case. So that's how we can prove that there will be a unique generator line, common generator line, if two lines to two different points are parallel. Now method one, let us discuss. The method one says, clearly to find the number of points of intersection, we need to select two distinct lines through two different points, as lines through the same point have that point itself as the point of intersection. This is correct. So what we are saying is, try to understand it diagrammatically. Let's say this kind of a diagram we are having. So there will be many lines through this particular point, many lines through this particular point, many lines through this particular point, like this, like this, like this. But obviously, since we do, if we take lines through the same point, then they all intersect at the point itself, but we don't have to count this point, right? In the question, it is given excluding the given points, the given 10 points. So we are not interested in the intersection of the lines through a single point, right? We actually wish to find 2 points through which we take a line and a line and they come to intersect, right? Because all lines passing through a single given point anyway don't generate any new intersection points. So that's something that we want to count, the new points of intersection that will be generated. So clearly we need to select two lines through two different points, and then see in how many ways can we do that, in how many ways can we select a pair of such lines, because and moreover they must intersect. They shouldn't be parallel, otherwise they will, if they don't intersect, then there is no point of intersection. So now please understand what we are trying to say, that number of lines through any point of, okay, before we proceed on calculation of this thing, what is the number of lines through any point? Obviously that would be equal to number of ways of selecting a generator line, because as soon as a generator line is selected, corresponding to that one line parallel to that line through that point, we'll be able to draw. So how many ways can we select a generator? So the generator line can be selected in the same number of ways as selecting 2 points from the remaining 9 points, because let's say we have a point P and we have remaining 9 points, right? So as soon as you select any 2 points out of these 9, a generator line is can be made, and from this you can draw an actual line parallel to this, right? So that's how the number of generator lines is equal to the number of lines through any point, and number of ways of forming a generator is simply the selection of 2 points from the remaining 9 points, because any 2 points give us a generator line. So that's why it would be equal to 9C2. Now, what will be the number of points of intersection? Point of intersection of new lines, basically, not the excluding the 10 points. So we first have 10C2. What is 10C2? Basically, we are selecting the points through which the lines shall pass. So for example, we have 10 points, right? Like this, like this, like this, like this, like this. So we are trying to find 2 points through which the so many lines are passing, so through which we will select the two lines to generate an intersecting point, right? Which will actually give out an intersection point. So we have first selected the points through which the lines are actually passing, and then into the number of ways of selecting two non-parallel or intersecting lines. So basically what we are trying to say is, let's say you have selected this point and this point. So there might be many lines passing through this. To be precise, they will be 9C2, right? And there will be many lines, let's say, passing through this point as well. Let's say this is one of the lines, another line, another line, like this, like this, like this. But observe that these two lines are parallel. So obviously we are not looking for parallel lines. They don't generate any intersection point only. We are looking for lines like this and like this, because they actually are not parallel, so they generate an intersection point, and that to a new intersection point, not an original one, right? So that's what we are talking about. Now call the selected pair of points as P1 and P2. These 2 points that we have selected, we have named them, let's say, P1, P2. The number of ways of selecting a pair of lines, one through each. So obviously from P1 you need to select a line, and from P2 you need to select a line. So obviously out of the 9C2 lines, you take any line. So let's say there are 10 lines. So one line, how many ways can you select? 10C1, which is 10 only. So 9C2 ways I have selected a line from P1, and from P2 also same number of ways. Now, how many of these pairs of lines will be parallel? That would be equal to number of ways of selecting a common generator from the remaining points. Here we are using the third observation, where we observe that from two distinct points, if two lines are parallel to each other, that can only happen if there is a common generator line, which we have already talked about. So since there were 10 points in total, 2 are already used. How many points are remaining? 8. Out of those, you select any 2, which will obviously give us a generator line, because any straight line requires 2 points, which can be joined, and a line can be made. So that's what we have done. So number of pairs of intersecting lines would be what? Total number of ways of selecting the two lines minus the cases when the pair was actually parallel to each other. So those pairs we have subtracted. So that is precisely what is going to give us the answer. N is equal to 10C2 into number of ways of selecting intersecting lines, which is actually 57,060. So I really hope you were able to follow this explanation. Now there is also a method too that we might that also helps us understand this problem in a similar way, but a slightly different approach. So the approach is, total number of lines would obviously be 10 into 9C2, because from every point there are 9C2 lines. So 10 into 9C2 total lines will be there. And since observation 1 tells us that there are no repeating lines, because look, there will be no overcounting, because a line through a point certainly cannot be also a line through another point. We have already discussed this. We have already in the first point said here that a line through one point cannot pass through another point. So they are all going to be different lines. So no worries of overcounting here. Now select any one of these lines. Okay, let's call it L through the point P. So we have selected a line L, right? Now, of course, how would have this been generated? Through some generator line, through some unique generator line, and we are calling that generator line as AB. Now all lines through A point or B point are going to certainly intersect L. Basically the reason is, let us say it does not intersect, then it must be parallel, but it can't be parallel because then the line through A must pass through B, but we have already seen that the actual lines that will be formed cannot pass through another point. So no matter, let's say you take this generator and you will make this line, right, from A. then you take this generator, then you'll make this line parallel to this. So basically all the lines through A will certainly intersect L because it can't be parallel to L, right? And same for B. But all, if we talk about the other remaining points except A and B, so all the lines except one which is parallel to the common generator AB through any point other than PAB will intersect L. Okay, so what we are trying to say is that we have the point P, we also have the point A, we also have the point B. Now we have already seen how many points lines through A and B will intersect, because all lines are intersecting from A and B to L. So all of the lines will count, but for any other point of the remaining, there will be one line which does not intersect L. Which one would that be? I'll tell you, look, this generator line, obviously it is parallel to this, and this point, so many lines will pass through this point also, right? But from this point there will also be a line which is parallel to this generator line. So these two then are going to be parallel, they will never intersect. But apart from this line, all lines from this point will also intersect L, because the only case when both these lines can be parallel is when they have a common generator line, as we have already discussed in point number 3 or in observation 3. So the common generator line is AB here. So that one case, except this line will not except this line, every other line through this point will intersect the given line L. So what we are saying is, this selection of second line that we are making, call it L dash. So number of ways of selecting L and L dash would be how many? First, you select L in this number of ways. Basically, out of all the lines, you select any one, because we have already seen total number of lines is this many. So any one you select out of them, and then we have to select L dash. So L dash we can either select through A or B. So from A, 9C2 lines will pass. We have already seen from every point 9C2 lines will only pass. So any of those lines you take, that will intersect with L. Same for B also. And then for the remaining 7 points, we take, so how many lines will intersect it? 9C2, but minus 1. One single line will not intersect, into 7. Why? Because number of points remaining is 10 minus 3, 7. Except P, A, and B, there are 7 lines, 7 points, right? So all the lines through them will intersect at these many points. So into 7 we have done. So that also gives us 114120. But there would also be a case when L dash is selected first, followed by L. Obviously that will happen. So right now what happens is, we selected L and then we selected L dash. But in counting all these ways, there would also be a case when L dash is first selected, then followed by the selection of L. So these are obviously representing the same selection, because if you select L first, then L dash, or if you select L dash first, then L, either way point of intersection still remains the same. So every point of intersection has been counted twice. Every such selection we have counted twice. So the number of point of intersection actually would be 114120 by 2, which also gives us the final answer as 57,060. So quite a brilliant problem, I would say, and quite time consuming as well. But after a thorough explanation, I'm hopeful that you were able to follow through and understand the explanation, and were able to see how to approach these kinds of tough questions as well. So make sure you like the video, comment down below what more chapters you would like to see in the future, and subscribe to the channel, share it with your friends, and hit the bell icon to never miss an update. And I'll see you all in the next one.